This is a test tube. It is kept in a test tube stand, and this silvery metal ribbon or the piece of metal is actually, this is magnesium. And now see what we are doing. Now we will add some water from the top of the test tube, and see, we have added acid from top of the tube, and this acid is dilute HCl. You can write it aqueous. Okay. You can write it like this. HCl, aqueous means solution in water. So if you observe that some of the bubbles are evolving from the surface of the metal. See, if I slow down the speed, then you can see very clearly. See, so in slow motion, you can observe evolving these bubbles. So what are these bubbles actually? These bubbles are of a gas that is hydrogen gas. So actually what is going there? Magnesium reacts with acid to produce magnesium chloride. The formula of magnesium chloride is MgCl2. It is soluble in water, and also hydrogen gas is produced. Why the formula of magnesium chloride is MgCl2? You have studied that magnesium belongs to group 2, so it has 2 plus charge. Chlorine belongs to group 7, so it is factive, and chloride has 1 minus charge. So as the compound is neutral, so the positive and negative charge should be equal. So definitely there should be 2 chloride. Or as per rule, what we do, the charge on one of the ion is made the subscript of the other element for writing the ionic formula of the ionic compound. So the formula becomes MgCl2. So for balancing, we can put here 2HCl. Okay, so actually this reaction is going there, and hydrogen gas is evolving that can be collected here. You can use your thumb to cover the mouth of the test tube. Okay. Now see one more thing. Okay. Now see, this is the test tube where we have collected the hydrogen gas, where the reaction of magnesium with HCl was going on. So see what happens. We have opened the mouth of the test tube, and we brought a burning matchstick near the mouth. And now you can hear the sound that what happens. See, have you noticed a pop sound? Because hydrogen gas is inflammable, it catches fire, it burns in air. So it produces this sound. You can watch this again. So this pop sound can be here. So this is the test for hydrogen gas. So similarly, as you have seen, that hydrogen can react with HCl can react with magnesium to produce hydrogen gas and its respective salt. So the similar reactions can be there. For example, any acid, any diluted acid, for example, HCl in aqueous can react with zinc as well, and it produces zinc chloride, that is aqueous, and hydrogen gas. And again, you can balance the chemical equation. And the same reaction can occur with iron or tin or any other metal. And even you can change the acid. Any acid can do this. Even if you are talking about an organic acid, for example, CH3COOH, that is ethanoic acid. Ethanoic acid, it gives the same reaction. I'm writing this equation downward. So when it react with, for example, zinc or magnesium, I'm writing it with zinc. So what happened in this reaction? In organic acid, only these ions, hydrogen ions with the COO, COOH, these hydrogen ions are acidic in nature. These are not acidic in nature. So these are acidic in nature. So only these hydrogen ions form hydrogen gas. So hydrogen gas is produced. It is only one, so for balancing there should be 2 moles. And the product that is obtained is zinc ethanoate. So there should be 2 moles of ethanoate for 1 mole of zinc ion. So this is zinc ethanoate. So actually what I wanted to tell you that whatever the acid is there and whatever the metal is there, but it should be above the hydrogen in electrochemical series. So it can react and produces hydrogen gas and form its respective salt. And another thing that this is a type of redox reaction because hydrogen is reduced to hydrogen gas. Here hydrogen is +1 and here hydrogen is 0. In natural state, every element is in 0 state, 0 oxidation state. So from positive to 0, it means it is reduction. But on the other hand, zinc is being oxidized because here zinc is zinc 2 plus and here zinc is 0. So this is as well as a redox reaction. And one more thing, these reactions are displacement reactions as well because metal displaces hydrogen ion from an acid to produce its respective salt. So this is a reaction of acid with metal. It can be categorized as the displacement reaction, or more specifically, it is metal displacement reaction. And as reduction and oxidation are occurring simultaneously, so this is as well as a redox reaction.